The next one is a couple of more fundamentally new capabilities, which we did because we could, because we were doing it from scratch and others cannot, are some really valuable capabilities for our kinds of applications, for enterprise applications, for, in fact, for any kind of an application. And those are things like insert only, partitioning, and scale out, and hot and cold, active and passive storage. So insert only is, when we have a column store, a great way to deal with transactions that come in is to simply insert them. And so you add new columns in there. Adding a new entry in here means taking a part of that record here and just making the right insert in the appropriate place. And you invalidate the previously held entry. So even when you have to update a piece of information, like you have to update an address of a customer or update some piece of information, then in column stores it is very advantageous to simply create a new entry and then as a separate process invalidate the previous entry that you had. The benefit of this is, in fact, if you depending on how you invalidate this, how you have your invalidation strategy, it is possible to recreate histories. It is possible to create audit trails. It is possible to do time travels. How did something change over a period of time? And that is an extraordinarily valuable capability. And in HANA, we get this natively. In fact, the update sequence operation is implemented in HANA as a combination of an insert and then an invalidation of the thing that was not that's not valid anymore. One other thing in HANA that is that is extremely important, and many databases did this after the fact. With HANA, we did this right at the beginning from scratch, and that is the ability to partition data and to scale out across machines. So this is this very fancy picture that Sanjay has drawn of maybe you do like that, and then this has 4 pieces, and then this one is like gazillion pieces and stuff like that. I don't know how to draw that like that. So you will see that when you see that icon in Hasso's slides, or that's Sanjay at work who came up with this idea of partitioning. But basically what it says is, if you have, let us say, a lot of information and you need to partition that across nodes, across machines that are connected to each other, you can dynamically partition them so that part of the data is in one machine and partly in another. That partitioning can be done by row or by column, meaning if you have giant columns like we have sometimes in fact sheets, in fact tables, or in point of sale data and stuff like that, where you have tons of information all in one column, then you can split up the column into different parts and send them to different parts of memory of one server or multiple servers. And of course you can partition columns, so you have one piece of the database in one machine and so on, or a combination of both of these things, and then unleash the codes that are sitting on each one of these machines into all of them, and you get really awesome performance. Typically we see performance scale up and scale out pretty much linearly. On a 16 node cluster, we often see performance improvement of around 11 times and stuff like that. So of course it depends on the nature of the question and how distributable or how distributed inherently it is, but HANA gives us these native capabilities which other databases don't have, which is to be able to run workloads across machines. And some of the more extreme examples that we have achieved, we once took retail data, which is anonymized retail data from one of our largest, super large retail customers, one of the biggest companies in the world, and they were doing something like 330 million transactions per day, and we took 10 years worth of data. Wow. So that is how much data? That is approximately 1,200 billion records. That's 1.2 trillion, in case you are counting. That's 1.2 and then 12 zeros after that. That's a very, very large number. It's 1.5 times the population of the world, 1 3/4 times the population of the world. So you can kind of guess who this retailer is. And we ran this thing on a 100 node cluster. Each node is 40 CPU cores, 1 terabyte of memory. And basically the incredible thing was, all the questions that we could think of in this particular case were between 600 milliseconds and 3.1 seconds response time. The only question that went past like 2 seconds was this one, this 3.1 second question, and this was quarter over quarter comparison over 10 years. So this is like, these are the kind of questions that on this kind of data would run for days on other infrastructure, and here in HANA that runs within a couple of seconds. So that is the benefit of partitioning and scale out. And one other capability in HANA is hot and cold. So there are times when we know about the semantics of the application. In financials, for example, we know that the active data in a financial record of a company is the current year. The year is typically the measure of a public company's financial information. And so a year, of course, is typically a little bit longer than 1 year, because you want to keep the open items from the previous year that came into this year and carried forward, as well as the items from this year that you will carry forward into the next year. So maybe 14 months of information for 1 year. And then if you want to do year over year comparison, so then you do also the previous year. So that's it. You don't need to hold more than that in active memory. You can cold store the rest of it, meaning put it into flash, into SSD, and then you get additional compression that way. So we can take 42 years of application know-how, bring that to bear to organize data in this kind of a tiered strategy with hot and cold data, so that we can get even more compression and we can get even better performance. And HANA enables us to do these kinds of things natively inside the database. So that was insert only, partitioning and scale out, and hot and cold.